So let's now look at some examples of simplifying logarithms using the power law. Remember, the power law said that if we've got m multiplied by log a of b, that this is the equivalent of the log of base a of b raised to the power of m. So let's now start looking at how we might actually use this in combination with some of our other logarithm laws as well. So let's say I've got 2 log base 2 of 7 and I subtract 3 log base 2 of 5. Well, first of all, I can use this log law here to rewrite each small part, so each term here. So this one is the equivalent of log base 2 of 7 to the power of 2, and that'll be subtracting log base 2 of 5 to the power of 3. So let's just evaluate that. So this will be log base 2 of 49, subtract log base 2 of 5 cubed is 125. And now I'm subtracting two logarithms of the same base. So we can rewrite this one to be log base 2 of 49 divided by 125 of 49 over 125. So you can see here we can start combining some of our log laws together to at least simplify or rewrite it in a new logarithmic form. But let's take a look at another example. Let's say I've got 3 multiplied by log base 10. Remembering when I've got log base 10, I don't have to write the little 10. We'll say log base 10 of 2, and I add 2 to it. So let's simplify this one. Well, the very first thing I need to do is I need to rewrite this with a log base 10. So the power in this case will be 2. So if I rewrite this here, let's do it in blue. This will be 3 log base 10 of 2 plus the log base 10 of 2. Keep in mind I'm not writing that small 10 in here. And let's now apply this law here to this first term. So this will be the equivalent of log base 10 of 2 cubed. And over here, we've got log base 10 of 10 squared, which is adding with log of 100. So evaluating this will be log base 10 of 8, so it'll be 8 here, adding with the log of 100. Now, of course, when I've got this, I'm now adding two logarithms together with the same base, that base of 10. So when I do that, I keep the base of 10 and I multiply these two numbers here. So this will be equal to the log base 10 of 8 times 100, which is 800. So you can see here, I can still use my logarithm principles to rewrite this or simplify it into a single logarithm. But let's take a look at one more example. Let's say I have the logarithm, we'll do base 5 this time, of let's say 81. And I divide that by the logarithm of base 5 of 9. To simplify something like this, I actually need to do the reverse sort of principles of what I was doing before, where I need to rewrite both the top logarithm and the bottom logarithm with the same base, with that same b value. Now, 81 can be simplified with a base of 9, so we can just rewrite this 81 with a base of 9. So we can rewrite this to be the logarithm of base 5 of 9 squared, and that'll be, of course, over the logarithm of base 5 of 9. Now the advantage of this is I've now got it in this format here, and I can rewrite it back over here. So I can rewrite this to say this is equal to 2 log base 5 of 9 over the log of base 5 of 9. Now you've got to remember that this is 1 times. We don't generally write that in here, but this is 1 times the logarithm of this, and this is 2 times the logarithm of this. Now, because these two are the same as each other, we can actually cancel them out with each other, and this is the same as saying it's 1 over 1, so it's 2 times 1 over 1 times 1, which, like I said, we can just cancel them out, and it equals 2 over 1. Now, 2 over 1 is just equal to 2. So this here, when we simplify it out, we can actually solve it, and it just equals out to 2. So you can see here, we can apply this power logarithm law with other logarithm laws to be able to simplify a variety of logarithm expressions.